Here's a scenario that plays out constantly on first deployments. USSH into your server, clone your repo, run npm install, type node server.js, and it works. You open a browser, hit your domain, and there's your app. You feel great. Then you close the terminal. And the app stops. Because your node.js process was tied to that SSH session. When the session ended, so did the process. So you try nohup node server.js and now it survives terminal closure. But 2 weeks later, a user hits an unhandled promise rejection and node.js crashes. It's 3 a.m. Your app is down. Nobody restarts it until morning. So you add some logic to catch errors. But then you deploy to a different server and forget the nohup flag and the process dies again. Running node server.js directly is fine for development. It is not production grade. It cannot handle crashes, reboots, or session management. It has no log management. It has no monitoring. What you need is a process manager, a daemon that wraps your application, handles its entire lifecycle, and keeps it running reliably no matter what happens to the underlying server or node.js process. In the node.js world, that process manager is PM2. A process manager sits between the operating system and your application. It's responsible for 4 things that node server.js cannot do on its own. First, crash recovery. When your node.js process exits, for any reason, the process manager detects this and restarts it automatically, usually within milliseconds. The exit reason could be an unhandled exception, an uncaught rejected promise, a memory overflow, or a seg fault in a native module. The process manager doesn't care why it crashed, it just restarts it. Second, startup on boot. When the server restarts after a maintenance reboot, power failure, or kernel update, the process manager starts automatically via the init system, systemd, and then starts all your registered applications. Without this, your app is down every time the server reboots until someone manually restarts it. Third, log management. Node.js's console.log output goes nowhere meaningful if you run it directly. A process manager captures stout and stare into log files, rotates them to prevent disk exhaustion, and provides commands to view them. Fourth, process monitoring. CPU usage, memory consumption, uptime, restart count, the process manager tracks all of this. You can see at a glance whether your app is healthy and how many times it's crashed in the last 24 hours. PM2 does all 4 of these things. It's the reliability layer that turns node server.js into a production-grade service. PM2 is a node.js package installed globally via npm. The command is simple, sudo npm install gpm2. The sudo is important here. When you install with sudo npm install g, it installs pm2 to /usr/local/bin/pm2, a system-wide location. This ensures pm2 is available for all users on the system, including when it runs as a systemd service during boot. If you installed node.js via nvm rather than the nodesource apt repository, you'll hit a complication. Nvm installs node.js to your home directory, and sudo doesn't know about your nvm path. The workaround is sudo envpath equals
/home//bin/home/mocached/.nvm/versions/node/v24.5.0/bin/us//bin/us/bin/us/home/mocached/.nvm/slash/node/b24.5.0/bin/node/b24.5.0/bin/node/npm install gpm2. But this is one reason why the nodesource apt installation is cleaner for production. It installs node.js to /usr/local/bin where sudo can find it. After installation, verify with PM2 version. You should see a version number like 5.3.1. PM2 is actively maintained and widely used. At the time of this recording, it's been downloaded hundreds of millions of times and is running on servers at companies you've heard of.
It's the de facto standard process manager for Node.js applications. One important thing to know, PM2 requires Node.js to run. If Node.js is upgraded, PM2 continues to work as long as the upgrade is compatible. PM2's own updates are installed with sudo npm install gpm2 at latest. The simplest way to start a PM2 managed application is PM2 start server.js. PM2 immediately demonizes the process, it runs in the background and returns your prompt. Run PM2 list or PM2 status and you'll see a table with your app's name, PID, status, CPU, memory, and restart count. PM2 start server.js name myapp gives your application a meaningful name instead of the default file name-based name. PM2 status shows myapp instead of server, which is much more useful when you have multiple apps running.
PM2 start server.js watch automatically watches for file changes and restarts the process when code changes. Don't use this in production, it causes unexpected restarts when log files or temp files change.
This flag is for development only.
After starting your app, the key commands to know: PM2 list shows all managed processes.
PM2 show my app shows detailed information about a specific app. PM2 restart my app restarts it. PM2 stop my app stops it. PM2 delete my app removes it from PM2's process list. PM2 log shows the combined output of all apps in real time. PM2 logs my app shows logs for just that app. PM2 logs error shows only the error output. These are your first diagnostic tools when something goes wrong. But running PM2 start server.js directly is not the production grade approach either. For production, you want an ecosystem configuration file. That's the next chapter.
The PM2 list command, also accessible as PM2 status, shows a table that tells you the health of everything PM2 is managing.
Learning to read this table quickly is an essential skill. The columns ID is PM2's internal numeric ID. Name is the application name you gave it. Mode is either fork, single process, or cluster, multiple processes. PID is the Linux process ID. Status shows online, running, stopped, or errored. Restarts is the number of times PM2 has restarted this app since it was registered. Uptime shows how long the current process has been running. CPU shows current CPU consumption. Memory shows current RAM consumption. The status column is the first thing to check. Online in green means healthy.
Stopped in gray means intentionally stopped. Errored in red means the process crashed and PM2 gave up restarting it. This happens when the app crashes too quickly in succession. The default is 15 crash restart cycles within 15 seconds.
The restarts column is extremely informative.
If it's 0, your app has been completely stable.
If it's 5 after 1 hour, something is wrong, your app is crashing and restarting.
If it's in the hundreds, your app is in a crash loop.
PM2 will eventually stop restarting it to prevent a runaway loop.
The uptime column tells you how long the current process has been alive. A 5-minute uptime with 50 restarts means the app is crashing every 6 seconds. That's a crisis that needs immediate attention.
When your Node.js app exits unexpectedly, PM2 doesn't just restart it blindly forever.
It has a restart policy designed to handle both recoverable crashes and unrecoverable situations. By default, PM2 restarts a crashed process with an exponential backoff. The first restart is immediate.
The second waits a moment.
Each subsequent restart waits longer.
This prevents a constantly crashing app from consuming all CPU in a tight restart loop.
The default max_restarts is 15 before PM2 gives up. The min_uptime is 1 second. If your app crashes within 1 second of starting, PM2 considers it a failed start and counts it against the restart budget. If the app runs for longer than min_uptime before crashing, the restart counter resets. In your ecosystem.config.js, you can tune this: max_restarts, 10 limits restarts.
Min_uptime, 10s means the app must run for 10 seconds before a crash is considered a successful run.
Restart_delay, 4000 adds a 4-second delay between crash and restart, useful when your app needs to wait for a database connection or external service before it can start successfully. The errored status in PM2 list means PM2 hit its restart limit and stopped trying. This is correct behavior. A constantly crashing app is not serving users anyway, and by stopping, PM2 prevents resource exhaustion. When you see errored, fix the crash reason, then restart manually with PM2 restart my app.
Node.js is single-threaded by default. One process, one CPU core. On a server with 4 cores, a single Node.js process uses at most 25% of your available CPU. Cluster mode is how you fully utilize multi-core servers. PM2 start server.js imax starts as many instances of your app as there are CPU cores. I2 starts exactly 2 instances. I0 is the same as imax. PM2 uses Node.js's built-in cluster module to fork multiple child processes from a master. The master process receives incoming connections and distributes them across the workers using a round-robin algorithm. Each worker handles requests independently. The key requirement for cluster mode: your application must be stateless. If you store session data in memory, e.g., a JavaScript object or array, that data is isolated to one worker, other workers don't see it. A user might hit worker 1 on one request and worker 2 on the next, and their session disappears. The solution is to move state to an external store. Sessions go in Redis. Cache goes in Redis or a database. Any state that must persist between requests must live outside the Node.js process.
If your app is stateless, which it should be for horizontal scaling, cluster mode is a free performance multiplier. PM2 start server.js IMAX and your throughput scales with your CPU core count. Here's one of PM2's most powerful features for production deployments. PM2 Reload. My app performs a zero downtime restart. Here's the difference between restart and reload. PM2 Restart stops all processes and starts them again. There's a brief period, typically under a second, where no processes are handling requests. PM2 Reload sends a SIGINT signal to each worker one at a time. The worker finishes its current in-flight requests, then exits. PM2 starts a new worker with the updated code before killing the old one. Traffic continues to flow throughout. The effect: your application can be updated with no drop requests and no downtime. Users experience zero interruption. This requires that your application handles SIGINT gracefully. In Node.js, that means listening for the SIGINT event, process.on, SIGINT, equals, server.close, equals process.exit, 0. This closes the HTTP server, stopping new connections, then exits after finishing any in-progress requests. For cluster mode applications, PM2 Reload is the standard deployment mechanism. For single instance, fork mode applications, there's an unavoidable brief restart period. Combined with PM2's startup configuration and your Git-based deployment workflow, PM2 Reload becomes the last step of every deployment. Pull new code, install dependencies, PM2 Reload. Your users never see a gap. PM2 comes with a built-in monitoring interface accessible directly from the terminal, PM2 Monitor. This opens a full-screen dashboard showing CPU usage, memory consumption, logs, and process status for all your managed apps in real time. PM2 Monitor is excellent for watching your server during a deployment or after a code change to verify everything is healthy. For web-based monitoring accessible from anywhere, PM2 Plus, formerly PM2 Keymetrics, provides a cloud dashboard. After connecting your server with PM2 Link NLT, secret_key and GT, NLT, public_key and GT, you get a web interface showing all your PM2 managed processes, their metrics, logs, and alerts. PM2 Plus has a free tier that's sufficient for most small to medium deployments. It allows you to see at a glance whether any application is down or crashing, trigger restarts remotely, and view historical metrics. For teams that prefer self-hosted solutions, PM2's metrics can be exported to Prometheus with a PM2 Prometheus Exporter plugin, and then visualized in Grafana. This gives you the same visibility integrated into your existing monitoring infrastructure. The key insight: you should never find out your app is down because a user tells you. Monitoring, whether PM2 Monitor, PM2 Plus, or Prometheus/Grafana, should alert you before users notice. Set up at minimum a simple uptime check that pings your app every minute and pages you if it doesn't respond. Let's lock in the core concept of this chapter. Your Node.js app is running on a production server started with no up node server.js and 1 week later, it crashes due to an unhandled exception. What happens? Option A, the app automatically restarts within seconds. NoHop doesn't provide crash recovery. It only prevents the process from dying when the terminal closes. Option B, the OS restarts the process because it detected the crash. No, the Linux OS has no mechanism to automatically restart crashed processes. That's the job of a process manager or init system. Option C, the app stays down until someone manually restarts it. This is what actually happens with NoHop. The crash is silent unless you're watching logs at that exact moment. You won't know until a user or monitoring alert tells you. The app is down until you SSH in and restart it. Option D, PM2 would restart it. Correct, but only if you were using PM2. If you're using NoHop, this doesn't apply. The answer is C. Without a process manager, crashes mean downtime until manual intervention. This is exactly why PM2 exists. The guarantee that PM2 provides, crash recovery, log management, startup on boot, is what separates a hobbyist deployment from a production-grade one. Next chapter, ecosystem.config.js, the right way to configure PM2 for production.